so now let's come to making the network greener. And we have here Amelia, who is working for a really long time already in the electrical engineering area and working a lot about networks. And now she's also working in standardization and especially looking into how to make everything greener and how does it work. She will tell us now.
Right.
So first, a big applause. Yeah, right. yeah.
Thanks. So welcome to my lecture. It's always nice to be in front of an audience. So my name is Amelia Andersdotter. I will be speaking about green Wi-Fi equipment, or more specifically, the road from European regulation into chip standards. This talk is largely based on my experience working for Sky Group and Comcast as their senior standards manager. And while I no longer do this job now, I would like to believe that I have left a mark in the space, which I will currently be sharing with you. And so these are some things about myself. You can also find quite a lot of things about me on the internet. This is a slide that was meant to contain an anecdote that was sort of adjacent, but I ultimately decided to skip it. So if you want in the Q&A section to hear that anecdote, you can always ask for whatever I was planning to say on slide 3. But let's not stay on it too long. So the European Union is a regulated space. The entire purpose of the European Union is to have similar laws and similar states and harmonized rules across member state border. We use this to remove so-called technical barriers to trade or rules, the purposes for which are making a product which could be legal in one case, illegal in a different state. So that is sort of the logic of the European Union market regulation. We want a product that you can legally place on the market in, say, Germany, to also be legally placeable in the market in, say, Italy. So a good and intuitive example of what this harmonization practically means for technical rules is electrical safety standards, because we all interact a lot with electrical objects in our daily lives. We know that there are some ways that we can create electrical devices in a way that they don't spontaneously combust. We can, for instance, have proper insulation on cables. We have a small LED on all electrical devices to indicate whether there's power connected to it or not. There's also standards for how many centimeters away from heat-conducting surfaces crumbs in a toaster are allowed to fall when you're using a toaster in your home. And so some threshold value for this, and if you comply with it, then normally your toaster will not catch fire. So that's very good. There's also other limit values that you could put for electrical safety, like the amount of voltage, wattage, impedance, like a bunch of things that they standardized. But the harmonization bit comes in when we think about like the number of centimeters that the crumbs need to go. And you think, well, different countries could surely have different conceptualizations of the amount of centimeters needed for a crumb not to catch on fire. And if that were the case, then a toaster which was legal in Germany might not be legal in Italy, so that wouldn't work. So we have regulations, laws that state an intention to have the same threshold values everywhere. And then we have technical regulations or standards that specify exactly what those threshold values are. And so technical standards in this case just make sure that your toaster is legal everywhere in Europe. So to indicate to consumers of the European Union, also to regulatory authorities, that you have a product which is compliant with European safety regulations, we have the CE mark. I'm sure that you've seen it on your devices at some point. A manufacturer can add this to their device if they have contented themselves that their device is compliant with the technical regulations that apply. And so I'll mention that also, that any test that you might require for your device to demonstrate compliance is also standardized. So we have organizations in the European Union that work on developing standards that specify at which air humidity should a device behave in a particular way, at which air pressure, temperature, and so forth. And so in the particular case of electrical safety standards, anything that deals with electricity generally, you have CENELEC, a multilateral organization that gathers delegations from national standards bodies. And these delegates then get to ponder and reflect on the threshold values and which standardized tests should apply. It exists since the beginning of the 1990s, when the European Union Inner Market project was formed. Standards governance is kind of a big field, but I'll mention very briefly that multilateralism in this case means exactly that. The members of CEN-CENELEC are state bodies. So normally, depending on which European member state you're from, you might know that in Germany, the national standards body is DIN, in Sweden it's SIS, in Belgium it's NSN, AFNOR is the French standards body, and they are members of CEN-CENELEC, which means that they get to decide which documents CEN-CENELEC adopts. And so this can be contrasted with some other organizations for technical standardization that you may be familiar with, like the Internet Engineering Task Force, for instance, implements it's not a multilateral organization. They implement individual membership per meeting governance, and anyone who participates in a specific meeting with the IETF is allowed to hum in consensus if they feel that's appropriate. There's other examples also, like 3GPP has organizational memberships where organizations get to vote, and so forth. But multilateralism is actually quite appropriate for an organization like CEN-CENELEC. Because over the 20th century, we've had a lot of developments in how we consider especially safety of products. Like we started out, I think, the 20th century trying to poison everyone with bromine in food, and then somebody realized that's not very great, so let's make a safety standard that say you can't use this chemical when you're producing edibles. And so all of the different states in the European Union used to have quite different rules for what it means to be safe in your country. And so a really big topic in the European Union is, for instance, durability of concrete, the stuff that we use to build houses. How do you make sure that your concrete that you produce in your member state can be sold in a different member state and still be considered safe for a dwelling? This is not a trivial problem. When you create the harmonized standards as well, because you need to set the threshold value somewhere, you always run the risk that your threshold, the European level threshold value, will be somehow lower or comparatively less safe than the previous standard that was applied in some member state. And so you have to, so CEN-CENELEC uses this multilateral decision-making procedure to make sure that any potential degradation of security standards is still acceptable to all members, and they felt that they had a say in that. And so this is like a rough path for the adoption of such standards in the European Union. We call these standards that you can use to demonstrate safety harmonized standards. It's like European nomenclature. Their abbreviation is EN, because the European Union likes to be confusing. But normally what happens is you have some, so skipping past the fact that we need political will and the entire legislative process, and there's the Commission and the Parliament and elected representatives, whatever, let's assume we already have a law which expresses an intention to harmonize some field. For instance, all electrical devices should have a standby mode. This law will then be obligatory for the member states to implement, and in order to sort out the details of what this technically... Huh? Huh? Okay. I can hear myself. I'll check.
Just make a short break. It was a little echo.
I see, yeah. Is it also talking too fast?
No. So at least not for me. So was she talking too fast? No. Yeah, maybe you talk too fast for the microphone.
Yeah, that's a technical problem.
Sounds good now?
Testing, 1, 2. Check, 1, 2.
No. Does this one work? Okay, so it's...
I can hear some form of sound from somewhere in this space. Yeah.
Okay. So... No, I think... Okay. So, should we switch to the handheld?
Test, check 1, 2, check 1, 2.
No. This sound better? Okay. I'm sounding better. Sorry, then you get this mic.
Okay.
Okay.
Should I remove this then? Or just wait for somebody to give me instructions? Have some good procedure.
Can I check this?
Okay, testing, 1, 2, check.
Okay.
This is better? I don't need this. Okay, I trust you. You're the ones, yeah.
Okay, so sorry again, and I think we were a lot of law stuff here, so I'm just moving from the stage because I have no idea.
Yeah, so how do we practically go about creating these kind of safe devices in the European Union? So we're skipping past the process of, you need a political process with like a proposal and a parliament and a vote and all of these political things. But let's assume that we already have a law which states something. For instance, any device that is placed on the European Union in a market needs to have a standby mode. This law would then be obligatory for all EU member states to implement. And in order to sort out what it technically means for any particular device, like what does it actually entail to be in standby, the European Commission can make implementing acts. They can also issue standardization mandates. And these mandates are then used as a basis for Senelec work to produce a standard. And so after that, it gets a bit fishy, because actually, in order for a standard to be like harmonized in the sense of always demonstrating compliance, the European Commission needs to put it back in a law of the European Union. It becomes kind of a part of the European body of law. And afterwards, you can demonstrate conformance with a standard, either by using the tests that are purposed for this conformance testing, or just by saying that you believe that your product is safe for consumers to use. And so this is used a lot for health and safety regulations, like you saw this maybe here also. We have these for food safety, seat belts, steel pipes, construction materials, cement. There's a rich body of case law in the European Union about what it means for a standard to be adopted, how it should be made available. It's interesting stuff if you're very interested in competition law. And there's also a lot of like wheeling and dealing between member states in this area. So all of these like small technical parameters, like how far away from the heating surfaces do the toaster crumbs need to be, all of that is big politics, because it determines who gets to be a successful toaster provider in the European Union or not. And you have that for any area. In food safety, I think normally when we hear about it in the news, it's because the EU made some threshold value that, for instance, illegalizes Danish cinnamon buns, or makes the Romanian mitch no longer legal to sell to consumers. But so these are like, it's a very politicized process all throughout, but you really only have politicians involved in step 1. Step 2 is executive functions, 2, 3 is executive functions. Step 4 is technical experts, formally. That they're just people normally who work in the industry who also do standardization work. But so I say health and safety standards because electrical safety is obviously not the only reason we have harmonized standards for your typical electrical equipment. Like even going past cement and toasters, there's a number of rules and regulations that these devices need to comply with. And so we have technical standards covering the safety of cabling, metal surfaces, etc., leakage current, harmful substances that you can use in a device, electromagnetic transmissions, test requirements for all of the above, standby mode for devices which are perpetually connected. And so it's actually this last bit here that is interesting for the green Wi-Fi. So effectively, we've had this idea in the European Union that we can steer market actors to produce devices that help us achieve common goals by imposing relevant market conditions on products that these market actors can then want to provide. So one of the common goals is like environmental goals, reduction of carbon emissions, or the reduction of household energy bills as a consumer protection measure. And the idea is if we introduce the right thresholds, we will make device producers make devices that somehow conform with these regulations. But so in order to achieve these two parallel societal goals of having better energy efficiency and also lower end consumer bills, the European introduced this obligation for electrical devices intended for residential use to have a standby mode. It's already there in the regulations since 2008. So this means if your TV is not in active use, it should turn itself off eventually. If your coffee machine, you created, your filter coffee, but then you forgot to drink it, and you left the house, then also your coffee machine theoretically should go into some lower power mode so that it reduces the risk of safety concerns, but also lowers electricity cost. And so we have this general high-level idea that devices which are not in use by a consumer should automatically turn themselves off or go into standby. But this introduces a lot of definitional issues, actually. What is standby? How do we know that a device is in standby? At which time does it need to enter standby after it's not in active use? Like, it's just a bunch of different questions that would have to separate the standby mode from any other type of mode that the device could be operating in. Right. But so this general requirement now in the regulation since 2018 is that a device, in order to be in standby, cannot consume more than 8 watts. And so this is how we have defined in law what it means to be in standby mode for specifically network equipment. This requirement actually turned out to be like a massive challenge for internet service providers that provide routers to consumers that want internet connectivity. Because in your home router, the vast majority of the energy consumption comes from the Wi-Fi chip. It's like 70–80% of all electricity consumed by a router is going to be, in any mode, going to be the Wi-Fi chip. They're very energy intensive. And so the standby mode for electrical consumption standardization does exist for Wi-Fi devices. We have Sensenelec defining the scenarios and tests that are required to demonstrate that this 8-watt requirement is fulfilled. These are the two applicable standards from Sensenelec that would tell an equipment vendor like which tests do they need to conform with in order to demonstrate that their device has a standby mode that complies with the limit values for what a standard mode is supposed to be. And so the challenge then for internet service providers, also equipment vendors, is how do you demonstrate compliance in spite of the Wi-Fi chip being very hungry? How do you get the consumption of the Wi-Fi chip down? And for a typical internet service provider, equipment vendor, router manufacturer, you have two options. Like, one of them is you can rely on the chip vendor to provide firmware for their chips, which might be proprietary, some secret sauce that is able to deactivate certain functionalities of the Wi-Fi chip when you're running the test to make it compliant. Or you have a second alternative, which is trying to rely on standardized energy efficiency features for network chips. And so currently we're mostly in alternative 1. I should say this also, yeah. So the standby mode technically, I suppose, is supposed to be activated when you're not in your home. So say that you were at home browsing the internet, but then you go out with your family in the park and you have a picnic, and then you want your access point to kind of automatically deactivate. But so it's actually quite difficult problem then. How do you make the chips contribute to your compliance with these energy efficiency regulations? I put in this slide to have kind of a value chain for wireless local area networks and make it more obvious what the next part of the talk is. And so far in this talk, I've actually mostly talked about laws, regulations, regulatory norms, how do you make your product legal for the European market. But all of these devices also contain privately standardized components. So a home router, for instance, will have an Ethernet bus, it will have a Wi-Fi chip, it will have the plastic casing, also has some form of safety standards complied to it. And so broadly speaking, these would be at least for the Wi-Fi chip, the entities that are involved in making sure that we can have green Wi-Fi. The IEEE 802 LAN-MAN Standards Committee are the people who make bus standards and chip standards. All of these things get incorporated into devices. You have other components that also get standardized by other bodies. They should technically also comply with all of these rules and regulations. And so it's very messy. But so chip vendors like Intel, Broadcom, Qualcomm, Huawei, etc., they are highly aware that this is a challenge for internet service provider to demonstrate compliance. Chip vendors are also the most kind of commercially powerful entities when it comes to bus standard and chip standard development, but not only. So they have usually delegations also that work on sense and elect defining the tests for what energy efficiency means. But basically, the chip vendors are the people who ultimately decide how do we implement features that make us fulfill the bare minimum requirements for energy efficiency. The problem with using vendor-specific solutions for energy efficiency is that it makes the chips more expensive. So anyone who's trying to buy chips is going to always prefer a standardized solution because that reduces the cost per chip. But so there's a reason that Wi-Fi has been constructed in a way that makes access points especially power hungry. It's not just accident or maliciousness from chip vendors. Many end consumer devices that rely on Wi-Fi connectivity, such as phones or laptop, you see here, I call them handsets, are battery driven. And so Wi-Fi chips intended for these devices have extremely effective energy save mechanisms built in. When you're not actively using your phone, the Wi-Fi chip in your phone almost completely powers down. And if it did not do that, your Wi-Fi, your battery in your phone would probably run out in like just a few hours, because there's just so many features that the Wi-Fi chip is trying to provide. But so, ironically, these power save features in the handsets have also meant that you push energy consumption into the access point, because it's the access point that gets tasked with a lot of the energy save functions. So it provides scheduling, queuing, trying to interact with handsets when they are activated, and so a lot of it becomes more energy consuming to run the router. But it's sort of logical too, because actually, if a laptop or phone is drained of battery quickly, you have consumers complaining, they will call customer service, want to change their device. But an access point, a router, that is trying to manage this power save function in a handset, it's always connected to the wall through a plug, so it has a constant energy supply. And so ultimately, if your phone runs out of battery, you notice it, but if your electricity bill is 5 euro cents more expensive at the end of the month because your router did a lot of scheduling tasks, you don't really notice that. So somebody is not hearing what I'm saying. Yeah, I understood. Yeah. So the problem is I hear myself really well, even with an echo. So I don't have a shared experience here.
Let's say something more.
Check 1, 2. Check 1, 2.
Yeah. Okay. Okay. So we're just trying to figure out what the problem is. So, okay. Yeah. It's not Wi-Fi technology. It's
some other form of technology. It's
sound waves behaving
wireless
strange.
Microphone.
Yeah.
Wireless microphones is like a super interesting also.
It's good now.
Standardization.
So just talk about it, and then the problem solves. So sorry again for interrupting you.
No worries.
And we have the batteries and the non-batteries especially. So yeah.
Yeah, okay. So the reason that we pushed a lot of the assistant tasks for the handset, for them to do better power save into the access points, the routers, is that they're always connected to a power supply. So you don't know, a consumer whose battery runs out in their phone quickly will be very unhappy, call customer service, it costs a lot of money. But nobody will look at their electricity bill at the end of the month and go, I pay 5 euro cents extra because my router is performing scheduling tasks for my laptop. No consumer will ever do this. The challenge, however, is that there's about 18 billion Wi-Fi devices on the planet. Since .11 AC, the kind of 2013 Wi-Fi standard, it's become increasingly common that consumers have several access points in their home. So even if, for any individual consumer, these 5 euro cents aren't a lot, and the extra scheduling tasks on the router isn't much, on aggregate, for the global market, if you can shave energy consumption off of an access point, you can make really big energy gains. And so it was on this premise that I went into the IEEE 802, which is the Landman Standards Committee. .11, they make Wi-Fi chips, and I'm sure in this audience, like a lot of people will actually know this technology as 802.11 as well. It's been branded for the past 20, 25 years as Wi-Fi, so this is how it's known on the end consumer market. It's the Institute of Electronic and Electrical Engineers Standards Association. They're very big on network standards like Ethernet and WLAN, based in New Jersey, US. They have other standards too, like in timekeeping, clock synchronization, electrical safety. The Standards Association is volunteer, like they call it volunteer-based. Any participant who goes into an IEEE SA meeting goes there as an individual engineer exercising their best judgment. And typically, if you do participate as a volunteer in IEEE SA, you have a sponsor who is somehow a corporate entity that pays for you to be there. And I have to add as a disclaimer that I do not speak for the IEEE 802.11 in any way. I think that's part of the rules that they have. But so I went into the IEEE 802.11 Technical Standards Committee for Wireless Local Area Network chips. With all of these societal changes in mind, 18 billion devices, eco-design efficiency, problems for operators, and so forth, and participated in drafting the next mainline amendment project authorization request. So this is now currently under development. It's called the .11bn. For those who've been using Wi-Fi for a long time, you might remember that .11n in 2008 created quite good speed. .11ac introduced a 5 gigahertz network and so forth. Now they're on BN, the BN amendment. And so it's currently being developed, and the chips will probably hit the market in something like 2028, 2029. So this is not a finalized project yet. But it contains an imperative on the chip vendors to introduce a mechanism to reduce power consumption for access points, including mobile access points, and then also improved peer-to-peer operation, which is less relevant. But so this was quite cool, actually. Like when I came to the 802.11, they were planning to make a 60 gigahertz network, and when I left .11, they were planning to make power-saving access points. But so you'll remember that I said earlier, or at least I tried to communicate, that those who place a product on the European market are responsible for demonstrating compliance of that product with applicable rules and regulations. To some extent, it's possible to rely on firmware mechanisms to demonstrate eco-design, compatibility of network equipment. Generally speaking, it's more cheaper to demonstrate compliance if you already have standardized technical mechanisms for such features. And so it turned out that in 802.11, there was broad support for enabling one or several power-save modes for access points, because internet service providers are not the only people who have this problem. You also have device manufacturers who are providing equipment for office areas and so forth, that they see a large potential gain. Now I will just share with you some thoughts that we had on how we can actually practically standardize these features, like which features practically can go into the chip. And I can talk about these things because there's patents and everything, so all of this is already disclosed or in the standard already, so I'm kind of legally fine in that regard. So this would be like the normal transmission pattern of a router. It transmits equally in all directions. You get you have your access point, and then you have a sphere of connectivity around it because it doesn't discriminate between directions. But we see like all of the handsets seem to be equidistantly on the left of the router. So you could say all of the transmissions that happen to the right here would be sort of wasted energy in a sense. And so actually we can sort of fix that with a technology or a technical feature called beamforming, which was not introduced as a power save measure, but as a way of making higher throughput available for handset devices. But it does sort of, you get higher throughput and also better energy efficiency because the router is trying to direct where it's broadcasting instead of indiscriminately broadcasting everywhere. But you see in this picture that there's still somehow an inefficiency in how the broadcasting happens. Like all of the handsets are equidistant, they're approximately the same distance away. So why would you want the router then to make connectivity bubbles that don't include these devices? You can make a protocol where you calculate the distance of the devices, and then you try to make sure that you broadcast at exactly only those effects that the handsets need to be connected, and that would sort of improve energy efficiency. Since the .11be amendment, which was published only earlier this week, we also have something called multi-link operation, which is when you combine the forces of several radios logically to create a more powerful aggregate kind of throughput network for the handset device. And so the multi-link operation MLO, which is envisaged for .11be, enables logical coordination of 2.4 gigahertz, 5 gigahertz, and 6 gigahertz networks if you have a tri-radio router. And that can be very convenient if you're, for instance, watching video or trying to do a teleconference or have some other very jitter, latency, or throughput-sensitive activity that you're engaging in. But one of the features that they introduced into the MLO was the ability to power down radios when you're no longer viewing radio. And this is good for energy efficiency because what actually consumes most of the the highest energy consumption is just keeping the radios alive, listening for stuff from the ether. So if you get a new router sometime soon with an .11be chip and it has MLO implemented, then technically you should be able to benefit from this kind of power save mechanism. And so the reason that I came to talk about this is at some point earlier this summer, I was in a bar in Brussels with a couple of friends, and one of them mentioned that she no longer believed in environmental regulations because she found a lot of abuse of environmental regulations, poor enforcement, fake companies being set up to dispose of toxic waste that actually just dug it into the ground. And she was quite unhappy with the way that regulations are enacted and also the practical effects that they have on society. And I think she was also a bit tired with the general lack of commitment by institutions to make sure that these laws work. But I thought about this woman and her story about toxic waste, and I felt I had a good counterexample of a story with this story about power save for access points. Because it is practically the fact that the European regulation has steered the priorities for one mainline amendment of the 802.11 standard. And so while it's true maybe that the European Union is not in general now or ever a prime example of an entity that is able to stand up for its own regulations, values, and laws, it sometimes works. Sometimes it works, and I think we have to keep that in mind before we become depressed. So, we see a lot of dysfunctional things. I'm aware of that. Like now, we have the European Commission trying to negotiate on security standards with American IT providers. Donald Trump is slapping 15% tariffs in order to make the Europeans not uphold their own regulations. We have dismal track record of GDPR, data protection enforcement in the European Union. Member states who are not implementing European Court of Justice decisions when it comes to data retention. For many in this community, the inability of the European governments to safeguard human rights is surely an open wound. The copyright kerfuffle is another area where public opinion and government corruption have long been at odds, and where we have a lot of technical development as well as legal developments that you wouldn't say are too inspiring. But I think Europe and all of us could do well to remind ourselves that rules and rules-based governance often works, and it's up to us to make it work and to take care of that common good, because I don't think that we have a better process of ensuring that our Wi-Fi devices can shave those 5 euro cents of your energy bill. And so sometimes things work out. That was my message. Thank you very much for your attention. I'll try to move into Q&A.
Yes, thank you. And sorry for the sound problems. And now we have more than enough time for questions. And we have a microphone here in the front and one microphone there in the back. And we have already the first question here.
Hello. Thanks for the talk. My question is if it's also a topic of educating the end users, because many routers have the option to limit the power from the menu or say always shoot full power and stuff like that. And from the technical point, it's often better to use lower power so you don't interfere with your neighbors and they don't interfere with you. So it would be better if everyone uses the low power setting, but most people, oh, I set it to max, then everything will work fine. So maybe it's also an educational issue. What do you think about that?
So I have this kind of slide on, technical was supposed to be dynamics at the IEEE 802, but I think it touches on your issue, that internet service providers are terrified of customer support calls. This is like their one optimization is to not get customers calling their customer service because it costs a lot of money. And so if it were possible to educate consumers in this way, and that would be beneficial for not creating interference with your neighbors, I think internet service providers would have already done so. Like they have a very strong cost incentive to do so. But you see here also like how the value chain sort of works, that in the typical case, both in the US and in the European Union, it's the ISP that chooses which device you actually have in your home. So the commercial pressure is on, the consumer practically doesn't have a lot of leverage to choose which device they have at their disposal, how that device can be configured. We have quite strict regulations in the European Union also for how much power you are allowed to kind of use in a wireless device. Educating, normally when an end consumer chooses Wi-Fi device, they, like a phone, for instance, I don't have my phone here with me, but so if, they spend the most time looking at just the camera, like 98 or 99% of the time that a user spends looking at a Wi-Fi ad is spent only looking for camera specifications. Wi-Fi is like a tiny, tiny sliver of a percent and transfer power of what the consumer will practically be concerned with in their daily lives. So we could try educating consumers, but it's not necessarily the most cost-effective or easiest way to do it. And having, as now we have the compliance burden on customer premise equipment makers, and then ISPs as kind of more informed consumers that can help drive energy consumption down. And I think that is just economically definitely quicker, but also easier.
Thank you. Any more questions? Yeah, next one.
Thank you for this. What was that anecdote from slide number 3 that you deliberately left out empty?
Yeah, well, it's an old grievance. It's another field where I think rules also matter, and where maybe the European Union is now moving into an area where rules work. So my grievance is specifically with computer crime legislation. I do not believe that it's well constructed. It is basically a subsidy of companies that don't take care of IT security in their systems by providing police resources. And so they knew this when they made, what is it called in English? I think it's just computer misuse, something like this in the European nomenclature. They knew this. Like in 1987, there was a report by the Council of Europe that said that we should be very careful not to over-criminalize the digital space, because then we're moving economic incentives from the entities that maintain these systems and putting them on the police, which is technically in a very poor position to remedy any kind of problems with an IT system. They repeated this observation again in 1989. I mean, so basically the problem with computer misuse is that any application of this criminal framework is already criminalized by some other framework. You are already not allowed to commit fraud. You are already not allowed to violate contracts. You are already not allowed to misrepresent things or falsify a signature. So you would ask, why can't we just use the normal technology-neutral regulatory framework that we already have? But it turns out that different member states in the European Union have different conceptualizations of authenticity and what is a signature, and how do you know when it's falsified. And so what the lawyers said in 1989 is that in spite of us already having a perfectly functional legal framework for criminal law to deal with any conceivable problem that could arise with information, we're going to harmonize around computer crime because it's fun with harmonizations. It's like a legal framework that exists only to harmonize. It was known that it would be over-criminalizing. And so now what the European Union is doing lately, and I know that you had a talk about this also yesterday, is that they're introducing things like the Cyber Resilience Act, there's DMA, DSA, Digital Markets Act, Digital Services Act, a bunch of regulatory frameworks that try to shift the economic burden for security back to the providers of the systems, which is where it should have been from the beginning. Like the cost center needs to carry its own weight. You know, if you don't make it, if you say that we will send in our police officers to compensate for somebody's lack of security investment, that's basically just making a weird kind of subsidy of a lack of investment in good IT security. And so it was kind of an anecdote I wanted to share. So as an example of a different case where the European Union is making regulatory frameworks that likely will have an impact. I know there's a bunch of technical problems with CRA, all of these acts, that people are worried about the details, but I think in the broad, the broad direction of where we're going, now we're trying to shift economic responsibility back to people who are actually able to carry that responsibility, which is good. So it's another example of kind of rules work. That was the anecdote.
Oh, yes, thank you. This was also my main question. So what was the anecdote from slide 3? So any more questions? So unfortunately, you haven't hidden another anecdote in slide 4 or so? No. 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 Okay. So then again, a big applause